This is 2.5, solving and graphing quadratic equations. So your essential question is, how do we solve a quadratic equation without factoring? So factoring is our biggest thing that we talk about. We've already talked about one of the ways, which was solving with square roots. Today we're going to talk about the other way, which is solving with the quadratic formula. So when we solve quadratic equations, we will usually want to choose the solving method based on the form. Okay, so the form of the equation is where we pick which one. Okay, so the first one is if the form looks like this. Okay, which is what we did in the last lesson. So the questions in 2.4b were solving, but they had you solving using factoring. So we have standard form where it's ax squared plus bx plus c, where a, b, and c are numbers, and factorable. That's important. So if it's in standard form and we can factor it, we factor to solve. The second way is still standard form. This is the new ones for today. You should have done this in other classes, but if it's standard form and not factorable, obviously we can't factor something that's not factorable. We're going to solve with quadratic formula. The reason things aren't factorable is when you'll see it's not perfect numbers, not perfect factors. We're going to have square roots involved in our quadratic formula answers. And the last one is the last thing we talked about last time, which was solving when it's in vertex form or descriptive form, where it has the binomial square, the thing we usually use for graphing. If it looks like what you'd graph, that is when we solve with square roots. So we move it over, square root both sides, remember plus or minus, all that good stuff. So this time we're going to have all of them. So the quadratic formula, that's the new thing. That is the important new formula here. So I'm going to highlight this whole thing actually, because you need to know the quadratic formula, and especially how to use the quadratic formula. It is very important and very helpful for graphing, or sorry, for solving. So we have factoring to solve when it's factorable, when it's not, quadratic formula, and when it's in the graphing form or descriptive form, that is our solve by square roots. Okay, so we're also going to have imaginary numbers sometimes. You're not always going to have two solutions that are real. Sometimes we're going to have imaginary solutions. So I, the imaginary number I, is the square root of -1. So if we ever have a square root of negative number, that is when we end up with imaginary. So and we rewrite it as I. Okay, and just to remember, I squared, if I squared it, I'd get -1. If I had cubed it, I'd have negative square root of -1. Remember, we do not distribute into roots. We have something outside and something inside. The only way to get something out is if it has a perfect square factor. And then I to the fourth, so I have this to the fourth is actually +1. Okay, it's not super helpful right now for this lesson, but for future imaginary number stuff, it's a nice thing to know. Okay, so first we have to see which one are we going to solve. So this is standard form, x squared minus 6x plus 8. Standard form, I'm going to check, can I factor it first? So I have x and x, I have 8 and 1, or 4 and 2. So x and x equals 0. So let's see if it's factorable. I need to make a -6. 8 and 1 can't make 6. 4 and 2 can make 6. They need to both be negative though, because it has to be a +8. So -4 times -2 makes a +8. Always check. -4x minus 2x makes -6x. Yes, it matches. We have factored it. So I'm going to solve this one by factoring. Oops. So I'm going to use zero product property. X minus 4 equals 0. X minus 2 equals 0. And I just solve. Add 4 to both sides, so I get x equals 4. Add 2 to both sides, x equals 2. Done. 2 real solutions. By the way, some of your problems ask how many real, how many imaginary, how many total solutions. So that would be 2 real solutions. There's no i's. The only time it's not real is if it has an I. All right, next one, remember it has to equal 0. That's important. We always make it equal to 0 first in standard form, especially. Solving by square roots, you actually don't have to make it equal to 0 first, which is a nice thing. But to factor, which in standard form we always check, it needs to equal 0. Okay, so we look. No GCF. Let's try our normal factoring. So it's 3x and x. So I have 3x and x. Okay, 18 has 18 and 1, 9 and 2, 6 and 3. So I'm going to have to try things. I need to make a 25. Okay, so that's interesting. If I'm making a 25, I'm going to be dealing with a semi-big number probably. So if I look at 3 and 6, that makes 18. If I added another 3, that would be 21, not enough. So if I look at 3 and 9, that makes 27. For the 2, I could make 29. Oh, but it's negative. So one of them is going to be positive, one of them is going to be negative. So 3 and 9 makes 27. I take away 2. That does indeed make 25. So I'm thinking that's the one I'm going to use. Okay, I want the bigger one to be positive in this case, because it has to be a negative, so 1 must be negative. And I want a positive middle term. So let's check. Negative 2x plus 27x makes positive 25x. It worked. We got it. This one was factorable. So we have it. So using my other color, 3x minus 2 equals 0. 0 product property. Hopefully you start hearing that and understanding what it means. So I'm going to just add 2 to both sides, divide by 3. Notice I'm not showing all this work anymore. I'm assuming you understand what is happening here. So add 2, then divide by 3. This one I subtract 9. And I got my 2 solutions, 2/3 and negative 9. Once again, 2 real solutions. And only 2 total solutions as well. All right, next one. Has to be equal to 0. So I have minus 4, minus 4. So I get 2x squared minus 6x plus 1 equals 0. So if I check the factoring, 2x and x, the only way to make 1 is 1 and 1. But I need to get a negative 6. So I get 2 and 1 makes 3. That's the highest I can go. This one is not factorable. I should erase my factors so I don't forget about that. It's not factorable. That means I'm using the quadratic formula. Okay, so the quadratic formula, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. You might have heard some jingles or things to remember this in previous classes. You need to know what they represent. Remember that a is in front of x squared, b is in front of x. So this is a, this number is b, and this number is c. So a is 2, b is negative 6, c is 5. Nope, that's not true. That is the wrong one. Sorry about that. So this is a, this is b, and this is c. So a is still positive 2, b is still negative 6, but c is actually positive 1. You need to get it equal to 0 first, just like factoring. Okay, so x equals opposite of b, so that's positive 6, plus or minus the square root of b squared. Negative 6 times negative 6 is positive 36, minus 4 times a times c. 4 times 2 times 1, 8, all over 2a. 2 times 2 makes 4. So notice I'm plugging things in. I'm doing some stuff in my head, using a calculator if you need it to do some stuff. And now I'm going to simplify. So I get 6 plus or minus the square root of 36 minus 8 is 28 all over 4. That's going to be a square root I'm going to need to simplify. So on the side here, I'm going to make a little 28 factor tree, 4 and 7, 2 and 2. So I have a pair of 2's with a 7 left over, meaning I have 2 root 7, right? The pair, whatever the number of the pair is, 1 comes out. Whatever is left stays inside the root. So I have 6 plus or minus 2 root 7 over 4. There we go. There's where the 4 comes from. So 6 plus or minus 2 root 7 over 4. And remember, we simplify. So we separate 6 over 4 plus or minus 2 root 7 over 4. And simplify everything. So the first one is 2 as in both. So 3 over 2 plus or minus. The 2 and the 4 can simplify. Remember, outside divided by outside. So that's 1 or just root 7 over 2. And that is one acceptable way to write the answer. I always write them out because when they ask for how many solutions, you would be amazed how many people write 1. When I have 2, plus or minus, remember, makes 2 solutions. All right, this is where people get confused because there's a square root. Well, was that real or imaginary? The only time it's imaginary if it's a square root of a negative number and I create an I. There are no i's here. There's no square roots of negative numbers, so this is still 2 real solutions. Okay, we ended up with 2 real solutions. They're just not nice-looking solutions, which you'll normally get from a quadratic formula. Okay. Next one, it's equal to 0, so I'm going to look at factoring first. X and x, 6 and 1, 2 and 3. I need to make 4. X and x, so I'm just looking at these two numbers. So 6 and 1 make 7, 2 and 3 make 5. If I subtract them, I get 5 and 1. So I'm not going to work. This is another quadratic formula. So A, remember, is positive 1. Don't forget about that 1 in front. B is positive 4, and C is positive 6. So I'm going to set it up. X equals opposite of B plus or minus the square root of B squared minus 4 times A times C. 4 times 1 times 6. So 4 times 1 is 4, times 6 is 24, all over 2A. Okay, so subtract. 16 minus 24 is negative 8. This is where we have a slight problem. So we can simplify it like normal, the 8 part, but that negative is important, and it's going to change what we normally do. So I have a pair of 2's with 1 left over. That's the same, but because it's negative, I'm going to replace the negative with an I in front. So it's negative 4 plus or minus 2I root 2, because there's a 2 that comes out from the pair, so 2I, that's the negative, root 2. So writing out an I is part of it. Notice the negative is not inside the root anymore. That is what the I represents. Okay, so I can separate. So I have negative 4 over 2 plus or minus 2I root 2 over 2. Since we're dividing, we can indeed simplify. Remember, adding and subtracting is when you need like terms. Multiplying and dividing, you can actually do. So I end up with negative 2 plus or minus I root 2, because the 2 and the 2 simplify to 1. 4 and 2 make negative 2. And once again, we're going to write out the 2 solutions. Negative 2 plus I root 2. That's my first solution. And negative 2 minus I root 2. And that's my second solution. So they both have i's, so this time I end up with 2 imaginary solutions. I'll tell you that it's not as important this time because we're going to usually end up with 2 real, 2 imaginary, but later lessons, being able to pick out which one's which is important. Okay, example 3. This is not standard form, right? I have the binomial squared. That is a key for knowing, oh, this is solved by square roots. Get the squared piece by itself. So I get x plus 4 squared equals 11 when I add 5 to both sides. Then I square root both sides. Don't forget plus or minus. So I set up my 2 equations without the parenthesis. X plus 4 equals the square root of 11. My other one is x plus 4 equals the negative square root of 11. So on all of these, I'm going to subtract 4. Use a different color. Remember, when we subtract or add, we have to only combine like terms. One is a root, one is not. So this is negative 4 plus square root 11. They do not combine. They are unlike terms. So be careful about that. This one is negative 4 minus the square root of 11. They are unlike terms. Okay, but they may be unlike, but they are still real. There's no square root of negative number. There's no I. These are two real solutions. Okay. So x minus 1 squared plus 4. So it's a binomial squared again. So that's a hint that we need to deal with square roots. Okay, so when I square root both sides, most people would say, well, no solution. That is not the case anymore. We have imaginary solutions that we can deal with. So I'm going to set up my two equations, but I need the square root of negative 4. So x minus 1 equals, so the normal square root of 4 is 2. Most people know that. Square root of 4 is 2. Square root of negative 4 is 2i. And so my other one is x minus 1 equals negative 2i. Because it's plus or minus. Don't forget that. Whenever you square root both sides, plus or minus. Okay, so I'm going to add 1. Be careful. Adding and subtracting only like terms. This term has an I. This one does not. So it's 1 plus 2i. That is as simple as it gets. They are unlike terms. Same with the other side. Add 1, and I get 1 minus 2i. Okay, in this case, they both have i's in them, so this is two imaginary solutions. So we can get real or imaginary using quadratic formula or square roots. If you're factoring correctly, you should only ever get real solutions from factoring. Okay, and then we can also solve with graphing. This is the only one of these I have. Oh, I have one more. Plus 2, get the square root by or the squared thing by itself. Okay, hopefully you are getting better at dealing with fractions. Multiply both sides by the reciprocal. The reciprocal of 1/2 is 2 over 1. 2 divided by 1 is 2. So I end up with x minus 2 squared equals 4. Square root both sides. Don't forget, whenever we square root both sides, we need plus or minus. So x minus 2 equals positive 2. X minus 2 equals negative 2. Okay, so when I add 2 to both sides, hopefully you're getting good at this. I get x equals 4 and x equals 0. So this one was two real solutions. Okay. Example 4, accurately graph f of x and g of x on the same axes. Then we're going to solve through graphing. So f of x will be this, g of x will be green, f of x first. So look at my shift. This is a left 1 up 4 with an a value of positive 1. So I'm using 1, 3, 5, 1a, 3a, 5a pattern. Don't forget that. So right 1, up 1, 2, 3, 4, over 1, up 1, over 1, up 3. That's off the graph, so I don't have to put it. Over 1, up 1, over 1, up 3. Same thing. So I draw in my u. That is f of x. G of x equals 0. That's a line right there. Okay, they do not cross. So the reason we call them imaginary solutions is because they do not graph. So on this, we would call this where they don't cross, right? They don't ever cross. They can't be equal then. No real solution. Notice I'm not just writing no solution anymore. It's no real solution. For absolute value, we would write no solution. They don't cross, no solution. Easy. For quadratic, though, we can get imaginary solutions. And imaginary solutions do not graph, but they are solutions, which is a really confusing thing for a lot of people. But it's a really important mathematical concept, actually, especially when we talk about physics with electronics and electricity. So I'm setting it up. F of x is x minus 1 squared plus 4. G of x was 0. And we can solve by square roots. And you'll actually notice we actually already solved this. X minus 1 squared equals negative 4. When we square root both sides, you always have plus or minus. So x minus 1 equals 2i, x minus 1 equals negative 2i. So we add 1, and we get our solutions. Remember, only with adding and subtracting, we can only combine like terms. So I get x equals 1 plus 2i, and I get x equals 1 minus 2i. So graphically, we just know there's no real solutions. They don't cross, no real solutions. Algebraically, though, we can get our two imaginary solutions. That is, like I said, really important for physics and understanding electricity and electronic components, so computers and stuff like that. They use imaginary solutions to talk about solving things in with electricity. If you're not going to go into a field that involves that stuff, yes, you probably will never ever deal with imaginary solutions again. But remember that in high school, and this class is a college prep class, so we got to prep every major, right? Unfortunately, colleges require this class, so everyone has to take it regardless of your major. But if you're going into and being a lit major, a business major, a bio major, you're probably never going to see this. If you're looking at chemistry or math or physics, you probably will see imaginary numbers, okay? And they will be actually important. If you have questions about that, I can tell you more about why we deal with imaginary numbers. Some of you probably don't really care, so I won't go over it right now. You just want to be able to work with them, okay? So remember your essential question, and then you answer your essential question with a 3-sentence summary.